solve this example and send your answers on the group. This is an object and here's a pivot. This is the object and here's a pivot. A force of 10 Newton and a force of 30 Newton is acting upward. The distance between the length of the object is 5 meters and distance between the two forces, this distance is equals to 3 meters. The question is find the resultant moment and find the resultant force. The question is calculate the resultant force and resultant moment. And this point is a pivot. This is a pivot or a point of rotation. Calculate resultant force and resultant moment. Solve. No need to copy the question. Just solve and send your answers on the group. So when we are adding a moment or finding a resultant moment, moment is a product of force multiplied by perpendicular distance. So if force is 10 here, the perpendicular distance from the pivot, the distance between the two forces is 3 meters and the length of this object is 5. So distance from the pivot, it's 5 minus 3, which is equals to 2. So when you calculate a moment for this force, it will be 10 multiplied by 2. And because both moments are in the same direction, so you will add, so this is 10 plus 30 multiplied by 5. So 10 multiplied by 2 is 20, 30 multiplied by 5 is 150. So when you calculate, it will be 170 Newton meter and the direction will be anti-clockwise. Because both moments are anti-clockwise, so direction of resultant is also anti-clockwise. But when you're finding a resultant force, you just take the force in their direction. Both forces are acting up, so if they're acting in the same direction, what we will do, we will add, so it will be 10 plus 10 plus 30, which is equals to 40 Newton. And the direction of the resultant is upward or up. Why not 30 multiplied by 3? Because whenever we take a distance, we always take a distance from the pivot. So distance of 30 Newton force, distance of 30 Newton force from the pivot is not 3. That's equal to 5, the total. We always take the distance between the force and the pivot. Another example, this is an object And this time the pivot is at the center, exactly at the center. And you're applying a force of 50 Newton. A force of 50 Newton from other side, or force of 100 Newton from other side. The distance of 50 Newton force from the pivot is 2, and the distance of 100 Newton force from the pivot is 1 meter. 50 Newton force distance is 2 meters, whereas 100 Newton force is equals to 1 meter. And the question is, calculate the resultant moment. Moment and calculate resultant force if pivot applied 150 Newton upward force. So the question is, calculate the resultant moment and calculate the resultant force. So how you will calculate the resultant moment first? What about the moment of this force? If I say this is force F1, and what is the resultant of the second moment due to caused by the second force? So moment of this one is 50 multiplied by 2. So 50 multiplied by 2. So 50 times 2, what we'll get? We'll get 100 Newton meter. And what is the direction? What is the direction of the moment caused by force 1? So force 1 is causing an anti-clockwise moment. It will try to rotate anti-clockwise. Same thing, what is the moment caused by 100 Newton force? It will be 100 multiplied by 1. 100 multiplied by 1 is equals to 100 Newton meter. What is the direction in which this will try to cause a moment? It will try to cause a clockwise moment. So one is causing a clockwise moment, another one is causing an anti-clockwise moment. So force 1 is causing a clockwise moment, force 2 is causing an anti-clockwise moment. If we need a result of these two moments, what we'll do, we'll subtract. So first one is causing 100 Newton clockwise, second one is anti-clockwise. So to calculate a resultant, it will be 100 minus 100. So what I will get? I will get 0 Newton meter. 0 Newton meter means that this object will not rotate or it does not have any turning effect. That's the first thing. Is it clear? The moment caused by force 1 is anti-clockwise and the moment caused by force 2 is clockwise. The force 2 is causing a clockwise and force 1 is causing an anti-clockwise. Force 2 is causing a clockwise moment. And force 1 is causing an anti-clockwise. If both moments are same, then the resultant moment is, because they are in the opposite direction, so resultant moment will be 0. Then the second part, calculate the resultant force if the pivot apply 150 Newton upward. So if pivot is applying a force of 150 Newton upward, So force by the pivot is upward and the two forces are downward. We need a resultant. So what will be the resultant? 150 is up, minus 50 is down, minus 100 is also down. You can see this 100 is acting down, 50 is acting down, so that's why it is negative. And 150 is acting up, so it is positive. So what is the resultant here? So plus 150, minus 50, and minus 100. So what we get? Resultant force. We get resultant force 0. So if the resultant force is 0 and resultant moment is 0, if the result of the moment is 0 and if resultant force is also 0, what we call this condition? We call this condition that object is in equilibrium. So when resultant force, how the pivot apply a force? So see, because pivot is trying to stop this object, according to Newton's third law, if you apply force on the object will apply an equal force in opposite direction to try to balance it. So the concept is when the resultant force is 0 and resultant moment is also 0, that condition is known as equilibrium. So object is in equilibrium when there is no resultant force. So when there is no resultant force and no resultant moment, simply we call the object is in equilibrium. If there is a resultant force or resultant moment, then the object is not in equilibrium. So these are the two conditions for object to be in equilibrium or balance. So the principle of equilibrium or balance, if an object is in equilibrium, the sum of clockwise moment about a point is always equal to sum of anti-clockwise moment. And the conditions for object to be in equilibrium, when something is balanced or the beam is balanced, the force on it must be balanced, so no resultant force, and there should be no resultant turning effect, or turning effect will be 0. This is a condition when object is in equilibrium. Take the screenshot of this. So whenever you're solving a question related to moment, most of the question, you assume that the object is in equilibrium to solve a question. Okay, the diagram shows three uniform beams, P, Q, and R, each pivoted at the center. The two forces acting on each beam are shown. A force of 4 Newton, 4 Newton, 5, 2, and 1.5 and 1. The question is which beams rotate clockwise? So to identify whether it will rotate clockwise or anti-clockwise, first you have to calculate the moment. So what is the moment caused by this 4 Newton force? What is the moment caused by this 4 Newton force? the moment caused by this 4 Newton force. So this force, and what is the distance from the pivot? So you have first you have to calculate the value. So here the force is 2 and the distance is, force is 4 and the distance is 2. So the moment which is caused 8 Newton meter, which is anti-clockwise, and a force of 1 Newton, a force of 4 Newton at a distance of 1 meter. So what is the moment caused? That is clockwise. 4 Newton clockwise, this is 4 Newton clockwise and 8 Newton anti-clockwise. What is the resultant direction, resultant moment for beam P? What is the resultant direction or moment for P? Which direction it will rotate? Clockwise or anti-clockwise? 8 Newton meter is anti-clockwise and 4 Newton meter is clockwise. What is the resultant? So it will be anti-clockwise. Why anti-clockwise? Because the anti-clockwise moment is more. We don't need a value, but just we have to identify the resultant direction. Then when you check Q, a force of 2 Newton at a distance of 4. So which direction, what is the moment? This will be 8 Newton meter. And what is the direction here? Anti-clockwise, and 5 multiplied by 2, that's equal to 10 Newton meter. So which direction the beam Q will rotate? Clockwise or anti-clockwise? So because the clockwise moment is more, so it will rotate clockwise. And when you check this one, 1.5 multiplied by 2, this is equals to 3 Newton meter. And 4 multiplied by 1, that's equal to 4 Newton meter. So 4 Newton meter is a clockwise and 3 Newton meters anti-clockwise. So this will also rotate clockwise. So which two beams will rotate clockwise? Beam Q and beam R. So Q and R. So what is the right answer? Option C is the right answer. Is it clear, this question? The diagram shows a uniform bridge 4 meter long and the weight of the bridge is 10,000. So whenever in a question they mention a uniform, something which is uniform, something which is uniform means the weight will act at the center. So a weight is 10,000. So where the weight will act? The weight will act at the center. And what is the value of this weight? It's equal to 10,000 Newton. For the previous question, you need a value first, and using a value, you are identifying what is the direction of the resultant moment. So you need the values to identify the direction of the resultant moment. So a weight is acting at the center, because why weight is acting at the center? In the question, they mention a uniform. So whenever object is a uniform, its weight will always act at the center. What is the lifting force on the bridge? How much force is there or required to lift? So whenever you are solving these type of questions, you have to consider the clockwise moment is equals to anti-clockwise moment. Or you have to consider that it was in equilibrium. The weight, which direction weight will cause a moment? A weight is acting. If I draw this again, you can see here the weight is acting down and weight is 10,000. And this is a point or pivot, and the distance from the pivot will be 2 meter because the weight is acting at the center. So which direction weight is causing a moment? So weight is causing a clockwise moment. So what is the clockwise moment? It will be 10,000 multiplied by 2. Now what is the anti-clockwise moment? A force, a lifting force, example F is there, and the distance from the pivot. What is the distance from the pivot for this force? The distance from the pivot is equals to 4 because the total length of the bridge is equals to 4. So it will be force multiplied by distance. So force we don't know, and the distance from the pivot is equals to 4. So F into 4 is equals to 10,000 into 2. And if we need force, so it will be 10,000 multiplied by 2 divided by 4. When you solve this, it will come out 5,000 Newton. So B is the right answer. Whenever you're solving a question related to a moment, you will consider the object is in. Whenever you're solving, I will repeat again, whenever you're solving a question related to a moment, you have to assume that object is balanced, clockwise and anti-clockwise moments are same. So in the question, the diagram shows a uniform bridge. So there's a bridge of length 4 meter. So length of this bridge is 4 meter and the weight is 10,000. So where the weight will act, because it's a uniform, whenever anything is uniform, the weight will act at the center. So weight of the bridge is acting at the center. And what is the weight of this bridge? It's equal to 10,000. And which direction this weight will cause a moment or rotation? This will try to cause a moment in clockwise. And there's a lifting force. A lifting force will try to cause a rotation in anti-clockwise. And if object is not rotating, the clockwise moment and anti-clockwise moment will be same. So the clockwise moment and anti-clockwise moment will be same. What is a clockwise moment? A force is 10,000, the weight of the bridge, multiplied by distance from the pivot. So what is the distance from the pivot? Because it is acting at the center. So if total length is 4 meter, the distance from the pivot will be 2 meter. So it will be 10,000 multiplied by 2 equal a lifting force. Which direction this lifting force cause a moment? Anti-clockwise. So that's lifting force example F. And the distance from the pivot, this is a pivot. So distance from the pivot is equals to 4 meters. So multiplied by 4. If 4 is multiplied, other side it will divide. So 10,000 multiplied by 2 divided by 4. So what is the lifting force here? When you solve, you will get 5,000 Newton as a lifting force or force required to lift this object. Is it clear? So whenever you're solving a question related to a moment, you will assume that the object's clockwise moment and anti-clockwise moments are equal or same. Yes, Tausif, you're right. The 5,000 is a minimum force. 5,000 is a minimum force required to balance it. So we need more than 5,000, but minimum force required to balance this is 5,000. After a force change, if it's more than 5,000, like 5,001, 5,002, then it will cause or start to cause a rotation. Why we multiplied by 2? Because the weight of the object is acting at the center. The weight is 10,000. So 5,000 is a minimum force balance. So we need a bit more than 5,000 to move it upward. That's why the closest answer here refers to 5,000, which shows it's a, because the weight here is 10,000 and weight is acting at the center. So if total length is 4, so distance from the pivot will be 2 meters. How you will know where the weight is acting? If you check the question, in the question, the diagram is a uniform bridge. So whenever they use the term uniform, it means the weight will act at the center. Whenever the term uniform is used, it means weight will act at the center. So if object length is example 4 meters, then the weight will act at the center 2-meter distance from both points. Okay, this question. Two mechanics, A and B, are trying to use a 2-person spanner or a wrench to loosen a nut on a large beam. Figure 2.1 shows the forces exerted by two mechanics. Mechanic A is exerting a force of 500 Newton downward, and mechanic B is exerting a force of 400 Newton also downward. Calculate the magnitude and the direction of resultant moment. So what is the moment caused by mechanic A? What is the value of the moment caused by mechanic A? So it will be 500 is the force, and the distance from the pivot, it's 1.2. So 500 into 1.2, you will get 600 Newton meter anti-clockwise. So mechanic A resultant moment is 600 Newton meter anti-clockwise. What about mechanic B? A force of 400 at a distance of 1.2. So this will be 480 Newton meter clockwise. The force is 400 and the distance from the pivot is 1.2. So 400 multiplied by 1.2. Now the both moments are in opposite direction. One is clockwise, another one is anti-clockwise. What will be the resultant magnitude of the resultant moment? The value of the resultant moment. Because they're acting in opposite direction, to calculate the resultant, we will subtract. So 600 minus 480, which is equals to 120 Newton meter, and the direction is anti-clock. Is it clear? Mechanic A is exerting a force of 500 Newton and point P is the pivot. So which direction mechanic A is causing a moment? The mechanic A is trying to cause a moment in anti-clockwise direction. And what is the moment? Moment is a product of force into distance. So 500 into 1.2, that's equal to 600 Newton meter. Mechanic B applied a force of 400 Newton and trying to cause a clockwise moment. So 400 multiplied by 1.2. So 400 multiplied by 1.2, that's equal to 480 Newton meter. So one is causing a clockwise moment, another one is causing an anti-clockwise moment, and I mentioned that if two moments are in opposite direction, to get the resultant, you will subtract. So 600 is anti-clockwise minus 480 is the clockwise. So resultant moment is 120 Newton meter. And what is the direction? That is anti-clockwise, because the higher moment is anti-clockwise. So as a result, this spanner or a wrench will rotate anti-clockwise. Is it clear now? The second part, the mechanic B reverses the direction of 400 Newton. So first, mechanic B was applying a downward force. Now the mechanic B is applying an upward force, because they mentioned he changes the direction. So now the force of the mechanic B is upward. We have to calculate the new moment. So now mechanic A is causing an anti-clockwise moment, as well as mechanic B is also causing an anti-clockwise moment. Both are causing the same direction moment. So this is 500 multiplied by 1.2, which is equals to 600 Newton meter, and 400 multiplied by 1.2, which is 480 Newton meter. But the direction, as the direction of the force is reversed, the direction of the moment is also reversed. So both moments are now anti-clockwise. When two moments are in the same direction, to get the resultant, we will add them. So what is the new magnitude of the new moment? It will be 600 plus 480, which is equals to 1080 Newton meter. Anti-clockwise. Then calculate the magnitude of a resultant force. What is the magnitude of new resultant force? What is the magnitude of the resultant? 400 is up, 500 is down. New resultant force, like a 400 is acting up, this 400 is acting up, and 500 is acting down. What is the resultant force? So resultant force is 500 minus 400, which is equals to 100 downward. Is it clear why? Because the force of 500 is acting down and a force of 400 is acting up. So because they are in opposite direction, to get the resultant force, they're asking for force, not about the moment. The forces are in opposite direction here. So resulting force we will subtract to get the resultant. Is it clear, this question, this example? I will share another link once this will end. And every class now I plan the last 10 minutes we'll do some questions from different past papers as a revision. Any doubt related to topic moment or the turning effect? The next link I will share after some time.